So I've been using reinforcement learning, precisely double DDQ network, aka DDQN, to train my AI. And with this algorithm, I have two networks online and target, and the goal is to minimize the loss between these networks. And both networks contain separate parameters, weights, and biases. These are for the online and these are for the target. And as you can see, whenever these networks instantiated, I initialize parameters for online but not for the target. And the reason is I initialize them using this function. And if we take a look at this function, I just literally copy and paste parameters of online to the target, and that's the way the parameters for the target gets initialized. And this is this is like the very first beginning of the training. It's just like the preparation for the training. And during the training, if we take a look at my old code base, during the training I used to call this exact same function during the training on this interval. On every this interval, this was set to 10k. So on every 10k steps, I used to call or update parameters of the target by just hard copying the elements of the online. And as you can see, this is the current code base, and I no longer call this function, but instead I use this function instead. And as you can see, with this function, I no longer like hard copy and pasting online to the target, but rather gradually copy and pasting or copy and pasting online to the target. Because so the tau is set to 0.005. So on the first run, this would contain elements from mostly from target and partially from the online. And more this function gets called, the targets gradually copy elements of the online rather than so this would be like jump to the target, because on every certain steps, in this case 10k steps, I just hard copy online to target and abruptly change the target. But with this one, this is set to 32. So on every 32 steps, I gradually change the or update the target parameters of the target. And this had to be better or stabilize the training, because like I just said, there's no sudden jump, and that sudden jump might makes outputs or prediction from the neural network jumps as well, which is would be like, so there would be jumps to these predictions as well, and these would be used for other calculations to use for computing loss. So there might be, I mean, I think there will be, most likely there will be jumps for the loss calculation as well, and that's not really good. So, but when you update parameters of the target gradually, there will be no like sudden jump. So the computation or forward propagation and all the loss computation would be stabilized, and so everything would be better. And this is pretty standardized now. I mean, using this soft update is way more common now than using hard update. So yeah, I've switched to using soft update. And after I switched to this soft update, the performance has improved, but I've observed my AI has been behaving fine. Before this training, he doesn't really performing well, and I noticed the reason is I have so I've observed that my AI is learning slowly, and I think the reason is I set the tau too small. I might have to increase it so that it would copy elements of online to the target slightly faster. And I think the reason I need to do that is because I need to think about the trade-off between the value for the train interval and the tau. The train interval is set to 32, so essentially I will be like effective tau would be this. So, and I thought I could like remove this train interval, but that's not really common. So I might I think I'm going to just keep this and keep the value 32 for this value and decrease the tau and see what's going to happen. And also, I used to, so I made my words smaller. I think I've mentioned this before. So now the floor is 512 by 512, and also I used to clamp my AI because the training was unstable, and but I don't have to. So my AI works or behaves well without these clamps. So yeah, I just removed it. The way this works is whenever he goes beyond this boundary. So I used to set the boundary so that he can know he can go he can go beyond 50 by 50 on X and Z by clamping his position, because I thought the world is too big for him, and I thought the size of the world is too hard for him to learn. But like I said, I made my small world smaller, and yeah, things has other things has improved, so I no longer need to clamp his position. So yeah, I removed it. And yeah, thanks.